In the natural world, some of the greatest engineers are almost invisible.
They don't use blueprints, computers, or machines. They work in silence, with nothing but instinct, vibration, and silk.
This is the art of the web, the architecture of spiders.
At first glance, a spider web looks fragile, almost accidental. But if you look closer, you'll find an astonishing level of order.
Many orb-weaving spiders create webs that are almost perfectly symmetrical. A central hub,
But the spider doesn't hold a ruler. It doesn't measure millimeters or degrees. Instead, it measures with its body.
With each step, the spider uses the length of its legs and the tension in the silk to estimate distance.
No tape measure, no drawing.
Only touch, tension, and instinct, repeated over millions of years of evolution, to create what looks like a perfectly engineered trap.
The secret of the web doesn't start with the design. It begins with the material.
Spider silk is one of nature's most impressive fibers. It's incredibly light, yet incredibly tough.
But strength is only part of the story. Silk is also elastic. When an insect crashes into the web, this is the moment of transformation. The viscous liquid protein is extruded and instantly crystallizes into.
And here is where the engineering becomes even more impressive. Most spiders don't use just one kind of silk. They use many.
Some silk is dry and rigid, perfect for the frame of the web. Some silk is sticky, coated.
Other silk is used as safe lines, anchors, or as wrapping material to immobilize a captured insect.
It's as if the spider carries a tiny factory inside its body, choosing the right material for each part of the structure in real time, like a scientist designing advanced polymers on demand. So how does a spider build this delicate machine? It often begins with a single line. The spider releases a thread into the air, letting the breeze carry it. When the strand catches on a surface,
From there, the spider strengthens the frame. It adds more anchor lines, forming a rough triangle or polygon that outlines the.
Next come the radial lines, stretching from the center outward like the spokes of a wheel. These spokes are crucial. They carry vibrations to the spider waiting in the middle, and they divide the web into sections, like rooms in a house. Then the spider begins to lay down a temporary spiral, a loose, non-sticky guideline that helps set the spacing.
Step by step, it walks from the center to the outer edge, leaving a path of silk.
Finally, the artist begins its true work. It replaces that temporary spiral with a sticky, precise capture spiral. The spider creates tight, evenly spaced circles, designed specifically to catch flying prey. Layer by layer, line by line. In just a matter of minutes, or sometimes an hour,
a complete piece of living architecture appears suspended in midair.
To us, a spider web looks like a simple trap. But for the spider, it's much more. It is also a sensor system.
When something touches the web, vibrations race along the silk like signals along a wire. The spider can tell
A struggling fly, or the approach of a dangerous predator.
a small insect creates a quick, sharp pattern. A larger animal, like a bird brushing past, sends heavy, chaotic signals.
Wind produces a constant, low-level tremble.
From its position near the center or in a hidden retreat, the spider reads these vibrations with incredible accuracy.
And what about damage? Torn threads, holes in the web. To us, that looks like a failure.
But for the spider, a damaged web isn't always a problem. Sometimes it's an opportunity.
A partially broken web might actually attract more prey, because it's harder to see in certain angles of light.
Others will simply eat the old web, absorbing the proteins, and then spin a completely new one free of.
It's upgraded and repositioned for a new day. In this way, the web is not just a static structure, it's a flexible.
We often walk past spider webs without a second thought. But each one is a masterpiece of natural engineering. A bridge between art and survival, between geometry and instinct.
The spider doesn't know the language of physics or the formulas of architecture. But through millions of years, it has learned to bend silk, tension, and space into something extraordinary. So the next time you see a spider web glowing in the light, remember, you are not just looking at a bit of silk. You are standing in front of a living work of architecture, proved, designed, built, and tested by one of nature's most remarkable engineers. Fade out. Suspended between the branches, the web is a masterpiece of engineering. Yet, as the night bathed in the golden light of dawn, the intricate geometry of the orb weaver's web becomes visible, each strand catching the dew. Bathed in the golden hour light, the orb weaver patiently waits. This intricate structure is both home and hunting ground.
For the orb weaver, the dawn is not just beautiful, it is an opportunity to rebuild.